And after turning off her clean, she must wait until its temperature reaches 200 Fahrenheit degree before opening, because it's too hot, no? They waiting get the temperature decreasing from 650 to 200. Before opening it and removing the ceramic piece. If the room temperature is 70, and the gauge reach 607 minutes, how long must she wait before opening the clean? Assume that the clean cools according to the Newton law of cooling. Okay, and they put a weird formula that I don't like. I don't like this formula. I like my formula, no? I explained in the lecture it was temperature at any time, temperature, capital T. Temperature at any time is equal temperature final plus parenthesis temperature initial minus temperature final multiplication by e to the kt. It's a formula. I need to identification what temperature is giving. It's giving a lot of temperature. No? It's giving the temperature initial. Okay, obviously is 650 Fahrenheit degree. Okay, one more temperature I have in my hand. When we have one temperature, okay, I want to call T1. I don't know why, because it maybe it's condition 1. Okay, is given the temperature is 200, is the temperature you need to open the door of the clean. And this situation is ready to open, no? ready to open. Okay, and it's giving no, it's not giving the time. So the time is exactly the thing I need to find, because the last question say how long must she wait before open? Okay, I need to find the time. This is my unknown. Okay, and one more information. Temper final is always the room temperature is 70. And they give me another temperature, let me call T2, okay, is 60 Fahrenheit, and this happens at T equal 7 minutes. Okay, to say immediately identification. Okay, in this problem, the time T, little t is measured in minutes. And I suppose that my final answer is expressed also in minutes. It's the time in this problem. It's the unit case using in this problem. Okay. We are supposed to we using these tempers. Find the k value. Find the k value. Okay, by the way, you know k is negative number because it's decreasing. Okay, let me try to understand much better. I propose you doing one sketch. At least for me, it's fantastic. I don't know if you like or you don't like. And we you see physically, it's a temperature to any time, and it's a time in minutes, and it's a Fahrenheit degree. Yes, the unit. At the beginning, get t equals 0. We have 650. And the temperature is decreasing according to this law, but not 0. You're decreasing to, this is asymptotically approached. horizontal altitude at the temperature of the room, okay, 70. After that, it's impossible below this because of the temperature. And this moment, I suppose that any heat is transferred outside, and that's it. But we have temperature 1 and we have temperature 2. Temperature 1, I suppose, okay, is here. Suppose. Temperature 1. No. Not here. I suppose, is 200, I suppose, here. Obviously, it's in between 70 and 650, no? But I need to find this time. This is my own problem. But to find the k of this exponential que characterize this exponential is given another temperature T2, is 600 Fahrenheit. And this occurred at the time 7 minutes. 7 minutes. That means that this information, let me call condition 1 so so now it's much better, I don't know, change the name of this temperature like a T2 and T1. Doesn't matter, it's not important. The name is not important, the conceptual is important. This is 2 and this is 1. Condition 1, everything is always in this problem is the 1 point is given everything. It's given the temperature, it's given the time. Therefore, the only unknown in my problem is k. Find the k, and using the k in the second part of the problem to the condition 2 to find the time. That's the thing I want. Let's do it. The formula, I come back to the formula. Temperature to any time is equal 70 plus 650 minus 70 e to the kt. Now subtraction is 580, no? Is 70 plus, isn't this together, combine 580 e to the kt. Okay, nice. Entonces, I'm using the condition 1, and remember the condition 1, the temperature is 600, is equal to 70 plus 580 into the k time, the time corresponding to that condition is 7. In this moment, we have one exponential equation, and the only unknown is k. Let's solve it. Some algebra. It's easy. It's 600 minus 70. I move 70 to the other side, subtracting, divided by 580. Okay, is 530 divided by 580. By now, we can cancel out that 0, 53 over 58. Is equal e alone, e to the 70. And you solve. Okay, easy. You apply logarithm both sides, natural, of course, here and here. Therefore, we have natural logarithm of 53 over 58 is equal 7k. Now divided by 7, both sides, k alone is natural logarithm of 53, 58 divided by 7. Boom. It's good. I have this answer. But this is not the final answer. This is the condition 1 using to find the k. And the k represents the rate of change of the exponential. In this case, by the way, it's negative. How do you know it's negative? Because 53 divided by 58 is a number less than 1. And any logarithm of the number less than 1 when the base is greater than 1, because the base is e in this logarithm because it's natural logarithm, and so because this logarithm, when you put in the calculator, is negative. And make sense. Now we apply the formula one more time, but using the condition 2. In the condition 2, the temperature now is 200. 200 is the moment to be ready to open the door of the clean. S equals 70, same formula, plus 580 e to the kt. But what's the difference now? Different now is that we have k value, is this value. And you substitution, and that's it. Let's do it. This is another problem. Okay. Similar algebra is subtracting 200 minus 70 divided by 580. This is 130 divided by 58, 0, so 580. Cancel out this. 13 over equal exponential kt. I logarithm again, both sides. This is classical solution of the complicated exponential equation. We have so far natural logarithm of 13 over 58 is equal kt, and t is the time in which the temperature is 200. So for t is equal natural logarithm of 13 over 58 divided by k. Now who is k? This is k. And my final answer is t equal natural logarithm of 13 over 58 divided by, well, you divide by k, but it's a fraction. You said you want this 7 you put in the top, right? Logarithm of 53 over 58. And the rest is calculator. Yeah, I need your help. Because one important objective in that part is that you be ready to manipulate exponential and logarithm using the calculator. And of course, the answer you trunk to the near minute, no decimal. And the answer is time, que es en minute. That this is approximately and round off to the near whole numbers, no decimal. Okay, let me see what is the participation now. Paisul, Gigi, Madeline, Joseph, Andres, wow, Kylie. Do you follow my guide? Do you understand the thing I am doing or no? Edward, Joshua, everything okay? It's the answer. It's the answer. Very well. Wait. It's Edward, no? Edward. I got the same thing. Okay. Edward, Jenny, 116 minutes. It's the answer. Okay. Corresponding with, let me see in the answer key, no, in the choice. Yeah, there you go. Option C. Everyone get this answer or no? Everyone get this answer? Yes, Gladys. It's waiting. Gladys, so far, Edward, Jenny, Gladys, the rest. Chelsea is a yes, sir. Some students need can do it in my virtual calculator or no? Some students need. So my question is, you can do that by yourself or no? You need I show you in my virtual calculator how you get that or no? Got it, got it. I know, Gladys. The rest, Joshua, my darling, Brianna, Gigi, Paisul. Come on, answer it. Just say something. No, no, I got it. I don't know. Because it's a review, no? It's a no lecture, a review. That's it, no more. After the test by yourself, that's it. End of story. No answer. Brianna, Joseph, Andres, Paisul, Gigi, my darling, Kylie Garcias. Are you there or no? Okay, Joshua. Okay, Andres. The rest is okay or no? I'm waiting. Okay, si you don't, no problema. I understand. I don't understand the test. I understand now. So do you want I do in my own virtual calculator or no? No. Andres. Okay, I understand. I got Andres. Somebody need help in the calculator? Unfortunately, I don't see your calculator. I see my own calculator. Okay. Any question in the solution of the problem? Look like complicated, look like easy, look like straightforward, look like horrible. Let me erase the board. Oh no. Erase, yes or no?
Yes.
Let me ask something. Do you see my whiteboard, right? Because I forgot, see I share, no, yes, Andres. Okay, the number 28 is similar. It's similar. It's similar. Is it a thermometer? Is a cooling also, no? Yeah, just say. It's a cooling, it's a cooling. Entonces, my thermometer reading 73 Fahrenheit degree is placed inside the cool storage room. Entonces, this is the initial temperature, no? I suppose. Initial 73. Is placed inside the cool storage room with the constant temperature of the 38. This is the final. Es obvio que my process, y I am doing graphically to understand the physics behind this. Time, temperature. Capital T, temperature. Little t, time. The initial temperature is 73. And the final is 38. And this is asymptotically, no? Es obvio que the temperature is start here. Cooling, decrease the temperature, pero never overcome this temperature because it's the temperature of the room, no? Okay, one more information is given que the thermometer read 67. We have one temperature, one is 67, sorry. And this happened at 13 minutes. Okay, this is 67, I suppose here. This is roughly sketch to have only physical idea. And this time is 13 minutes. This is the condition one que help me to find the K value. Okay, how long? Time again, 60, before it reached 60. I have another temperature too, okay, 60. but I don't know at what time, how long. This is the unknown, the time for this condition, condition 2. Condition 2, suppose 60 here. I need to find this time. This time. Okay, this time is 13. This time is bigger than 13, condition 2. Super clear?
Yes.
Do you like, let me ask a question, by curiosity. Do you like this sketch that I'm doing graphically? It's more clear. Yes or no?
Yes.
It's more clear to understand. No, okay. Some students say, no, I don't understand very well. I suppose it's obvious, right? But it's okay. Everyone is, yes, help. Okay, now, the formula. What is the formula? The formula is easy. The formula is always the same. Temperature to any time is equal to temperature final plus temperature initial minus final e to the kt. In our specific problem, final is 73. No, 38. It's a final. Initial 73. This is plus 73 minus 38 e to the kt. Therefore, you're subtracting 73 minus 38 is 35. 38 plus 35 e to the kt. Yeah, 35. Yeah, and it's my formula, my specific formula in that problem, according to the condition that's given at the beginning. Okay. Now the only unknown is k and t for the condition 1 and condition 2. Condition 1, the temperature was 67. So I assume that this guy is 67 is equal to 38 plus 35 e to the k and multiplication by the time, because the time is 13. The only unknown here is k. Therefore, it's 67 no? Minus 38 divided by 35, no? It is 20, 29, no? 29. 29, 67 minus 39.
Yes, it's 29.
Yeah, thank you. You help me always. Who are you?
Gladys?
Oh, Gladys. Divided by 35. Okay, Gladys. Now, and the other side, we have a to the 13k, you know? What should I do now? Tell me. Tell me, Gladys.
ln.
ln. ln of this. And ln of this. And what is the reason? And what is the reason that that part and that part is cancel out each other? What is the reason in your own word? Not only always Gladys, another student maybe, no? Que one participate. Because Jenny say, I don't understand very well your answer, Jenny, but maybe you are right. Jenny,
Sorry.
right.
What I mean is like they're basically interchangeable. Like if you see ln, the base is e, so you can just like.
This is the idea. So this idea is fundamental in this idea. Look, it's a property tree. We have logarithm, and the base is the same of something they call x is equal to x. In that order or in that order, look, e to the ln of x is also x. Property 3 or property 4. Now, this is k, no x. Now, k alone is equal ln 29 over 35 divided by 13. Okay, now let's move on to the condition 2. In the condition 2, the temperature is 60. the equation is the same. But now I know the K, this expression, I don't know T. It's my unknown. How long? Temperature decreasing to the 60, no? Okay, so let's do it quickly. This is 60 minus 38 divided by 35. This is subtraction. It's 22, no? 22 or 35 equal e to the kt. You apply logarithm again, both sides. And logarithm you see is magic because convert the logarithmic equation in linear equation. No exponential equation anymore. This is kt. Therefore, t, and my problem is logarithm of 22 divided by 35 divided by k. And who is k? Well, okay, I replace for this. Oh, much better. Much better. You put ln 29 over 35, and the 13 you put in the top like that. Makes sense, all right? Okay, cool. What's the answer? Remember, approximate with to the whole number. All. Okay, time to compute. Everyone. Thirty-two. That's the answer. 32 minutes. Let me know who get that. 32, no? 32? 32 minutes. Who more get that? This answer. Paisul, you don't participate today? Paisul, are you there or no? Gigi, Stouffer.
Yes.
Okay. You can do that in your own calculator or no?
No.
Do you want to explain? The fantastic way would be, okay, I have in front of you, I take your calculator in my hand, I show you how. But the problem is que es virtual, doesn't virtual, I have another calculator different, but it's the same functions, no? Do you want to do or no? For you?
No.
No, why not?
I don't have the calculator with me.
Okay, you don't have calculator in this moment, no? Pero I suppose que you need to have calculator for the test, no? Yes or no? Everyone have calculator, no? I say at the beginning, yes. Without calculator, you cannot pass this class. Because we are working with the functions special, it is impossible to compute by hand. By hand, a piece of paper, no. We need a special function. So how I can help you? What can I do for you? Paisul? Nothing. My darling, come on, Faisul, tell us something. My darling, are you sleeping, no? Scientific calculator, of course, Andrés. Scientific calculator, no, pero no sophisticated, cheaper. Okay, no science fiction. They are science fiction calculator, no. I have both. I have science fiction, but I have a cheaper calculator, like that, look. This calculator is easy, it's 12 bucks in Walmart. Andres, it's exactly I want. Okay, this is fantastic. Fantastic. Andres, you get the same answer 32 minutes or no? Andres? Yes. My darling is sleeping, no? My darling, you are sleeping. Or no? My darling, say something. At least you say, I am sleeping. And what about Gigi? You are also sleeping. Wow. Unbelievable. Okay. Okay, don't cry. Um, let's move on to the next problem. See, you have no question, no? Everything is okay? Everything good, Andres. Okay, Andres, so now let's move on to the next problem. Okay, the problem 2029, no? 29? Let me see. Okay, the answer for the question 28 was 32 minutes. Look at that. Uh-huh. And see. Now, next question, next problem application is about logistic model. Logistic model. Logistic model is different. Logistic model, the formula for the logistic model is, it's about population, but it's another law. The formula is population to any time is equal carrying capacity is constant population, so it's total 1 plus b e to the kt. It's the formula for the logistic model or logistic exponential, either way. The difference between this model and the other model is in the exponential growth, we have no limit to increasing. This is time, this is population. It's exponential like that, and continue forever. It's infinity, uninhibited. Logistic, no. Logistic maybe start at the same point, but we have the carrying capacity in which stay the population, KC, the carrying capacity. That's the difference between logistic and uninhibited exponential or exponential growth. So in this case, it's given something. Let me show you this. We want to know, so the logistic growth model is given by, okay, compare population to any time. And this problem is 1,540 is the carrying capacity. C is capital C is 1,540. 1 plus 0 0.0 37.5 FB e to the something k is minus 0 0.0 no 0.314 0.314. This is the formula for the logistic. And they want to know what was the initial amount of bacteria, because it was the bacteria. Model the amount of bacteria. Bacteria population initial. Initial means at t equals 0. When you hear the word initial, it's t equals 0. I'm plugging in is 1540 1 plus 37.5 e to the minus 0.314 times multiplication 0. And any number multiplication by 0 is 0. And 0 have no sense to talk about negative or positive. 0 is 0. And e to the 0 or any number to the 0 is 1. That part is invisible. And the only thing you should do is computation that part. This is taking this divided by 38.5 0.5, no? Because it's 37.5 plus 1. And now put in the calculator division, but this is no special. This is just division. 40, 40, 40, 40, 40. 40 what? 40, 40, que es de option A, ¿no? 40, 40. I suppose que es 40, pero es 40 bacteria, ¿no? Initial amount, yeah, 40 bacteria, okay. Easy, super easy. What page it is? This is the page number 9. Do you understand this problem of the logistic model? We have one more complicated. 30, the problem 30. It's more complicated. Yes, okay, Jenny says yes. Okay, Jenny, entonces erase that and try to find the other page, que es page number 10. Try. Page number 10, which, what the hell? Here. Chapter 3, chapter 3. Oh, chapter 3, page number 10 is this. Wow. Exactly. It's a page number 10. It's the last problem, the last word problem of the logistic. Okay, the formula is given is population to any time is equal 1000 divided by, again, bacteria is 1 plus 19 e to the minus 0.343t. Okay, entonces now, bueno, I need to know bacteria in a 1 hour, no? In a 1 hour is 6, no. Is I need to find when is the time, when will the amount of bacteria is be 680. So this is 680. Equal 1000 divided by 1 plus 19 exponential minus 0.343t. I need to find t. I need to solve in t. Okay, what is the manipulation? Well, there are many ways, many. However, I consider that the best way, in my opinion, is you apply like a cross multiply, but different like that. Look, I put 1 plus 19 e to the minus 0.343t to the left. I put 1000 divided by 680 to the right, dividing. And when you divide this, you put in a calculator, you get 25 over 17. I put in my calculator. Now my goal is t, remember. I move 1 to the other side, 19 e to the minus 0.343t is equal to 25 over 17 minus 1 by subtracting here. Find the least common denominator, okay, 17, we have 25 minus 17 is 8, 17. Okay, little by little. Now you divide both sides by 19. It says e to the minus 0.343t is equal to a over 17 times 19. I move 19 divided both sides. Okay, is a over 322. Multiplication 17 and 19. Now to be ready to apply logarithm on both sides. ln here, ln here, but much better ln here. And yeah, I know que ln and exponential cancel out. We have minus 0.343t equal ln of a over 323. Okay, finally, solve for t, divide both sides by this negative number. Okay, T alone is equal natural logarithm of a over 323 divided by negative 0.343. And now, wow, it's weird because the answer is negative, Professor. No, the answer never is negative because we are talking about time, and time is always positive quantity. Okay, but the problem is que logarithm of the a over 323 is a number, a over 323 is a number less than 1. And less than 1, when you complete the logarithm, the answer is negative. And negative divided by negative is positive. Okay, wait for you for the calculator. Come on. Another participation. Always doing Edward, Gladys, Joshua, Jenny, Chelsea. Any another participation? Andres, Joseph, Brianna, Rachel. Wow. Rachel, you are late, no? It's 11. Yeah, 11. Actually, they round.
We round up because my answer I got 10.78.
Es the answer. Es the answer, Jenny. 10.78 is exactly the same answer you see in the here in the package. It's 10.78 hours. Okay. Guys, tell me something. How do you feel in the word problems? I suppose you don't lie, no? Or you lie? You lie or you don't lie?
I like them. Once you figure out the formula, it's easy. Just
Yeah. You it's the formula. Okay, you don't need to memorize, of course, no. You have in the piece of paper the collection of the formula and you apply the condition and the rest is algebra. Okay, algebra of the exponential and logarithmic equation. Let's practice now solving logarithmic equation. 31 is logarithm base 7 of t. Remember, guys like so much, put the parentheses, always. Some people don't put the parentheses, but you understand. It's a typical logarithmic equation. Okay, entonces sí, because always you condensing. You have, okay, when you have logarithm in the right hand side, in the left hand side, not necessary you moving everything to the one side. No. You condensing aquí in the left hand side, these two logarithms in only one, using the property number 5 because of plus. And this is logarithm base 7 of multiplication t times t plus 2. And this bracket is the bracket que is like in the parenthesis of the argument, equal logarithm of 7. And now when you have, if you have two logarithms or two exponential and the base is the same, it's because the argument is this and this is equal each other. Now my equation do not contain logarithm, it's just quadratic equation. Okay. Now you apply distributive property, t squared plus 2t minus 35 equal to 0. Our big problem, you reduce in one quadratic formula, and the quadratic formula you solving in the way you prefer, using the quadratic formula or in this case easy by factorization. Yes or no? Yes or no? It's a T. What is the combination? What is the combination, Andre? By factoring. Yes.
7 minus 5.
7 and 5. And you don't worry too much for the sign. You adjust the sign now. Because 7 times 5 is 35 and 7 minus 5 is 2. Cool. And you adjust the sign. What sign? What sign? Who is positive? Who is negative? Both negative or both positive? What do you think? Oh, it's obvious. Okay, no. This minus indicates us que es different sign. And this sign gets positive. Always you assign to the big number. Positive and negative. Therefore, one solution is negative 7. Another solution is positive. And this is the answer, no. No, remember, the logarithmic equations are picky. Therefore, you need to check it. You need to check it in the original to verify if this answer is okay or no. It's obvious that this is not okay. This is wrong. Because, you know, inside, you try to check it, you immediately realize it's impossible because logarithm of base 7 of negative 7, wow, no, undefined, to be undefined. Fine. So this is wrong. Not always happen that the negative is a bad guy. You see another example that negative is good. You plug it in. But the impossible thing is that you cannot compute logarithm of negative number. And let's check it 5. Because sometimes happen that the positive doesn't work, but sometimes yes. So I need to prove somehow que logarithm of base 7 of 5 plus logarithm of base 7 of 5 plus 2 que es 10 is 7, sorry. So you plug in 5 plus 2 is 7 should be equal to logarithm base 7 of 35. And this is obvious it's true. Because one more time you apply the property number 5. You condense this and this in only one. And that's it. Leave it like that. If you want, you delete this, 35 equals 35. It's okay. And the solution 5 work. The solution negative 7 doesn't. The solution 5 is good. The C option. Any question? That's what 31st. Guys, say something. Do you understand or you don't understand? Clear or confused? Clear. Okay, Annie. So now, let's move into the next. Next is 32. 32 is logarithm of base 5 of y plus logarithm of base 5 of 13 minus y is equal to logarithm of base 5 of 30. Wow, it's easy, it's similar, right? One more time, you condense in this only one logarithm base 5 of the multiplication y times 13 minus y equal to 5 of 30. Now I know that this part is cancelled. So y times 13 minus y. Unbelievable. Now we get the equation que have no logarithm. Okay, this is quadratic equation. I guess so. It's 13y minus y squared minus 30 equal to 0. Okay, let me multiplication by -1 whole thing. And we write y squared minus 13 and y plus 30 equals 0. Okay, nice. I like that. And the thing I did was multiply by -1 both sides, and 0 multiplied by -1 is 0 because 0 have no sign. And it's ready to apply factorization or no? You see the combination can open the door of the factorization or no?
15 and 2.
15 and 2, maybe. Maybe. It's okay. 15 and 2, maybe. All right. So 15 times 2 is 30. 15 minus 2 is 13. But unfortunately, we have another combination because this combination doesn't work. And the reason it doesn't work is because you're subtracting. And when this sign is positive, I suppose that both solutions has the same value. Subtracting is no good idea. Do you understand this or no?
Yes.
They are another combination or no?
3 and 10.
3 and 10. Very well. In this case, yes, because both are negative, no? Negative 10 times negative 3 is positive 30, and negative 10 plus negative 3 is negative 30. One solution is 10, and another solution is 3. Guys, important. I want to see in the test. If you leave like that, I put 0 for you. Because you need to know that the logarithm equation, one important part is solution, checking the solution. I need to verify 10 and 3 into the original equation. But the checking is extremely important. You split the paper into part, you put the checking part for both. X equal 10, not x is y. And check for y equal 3. And verification, see, there one case no good, or both are good, or nothing is good, there's no solution. Okay, now you plug in. It's basically logarithm of base 5 of 10, suppose 10, we're doing for 10 first, plus logarithm of base 5 of 13 minus 10 get 3 should be logarithm of base 5 of 30. What do you think about this statement? Is true or not? It's true. Why? It's true. Genesis is true, but I need to understand why. What is the reason? Because you apply the property phi, this property say that we can condense it in only one logarithm, que es the multiplication 10 and 3. Let's check it now. It's the same. Oh, it's the same. It's the same. It's the same. Yes, it's the same. Genesis is the same. So basically, see, I check it for 3, logarithm base 5 of 3 plus logarithm base 5 of 10, because 13 minus 3 gets 10, should be equal logarithm, and you get exactly the same idea. Therefore, in this case, both solutions are good. And the solution is 10 and 3, but positive, no? Like that. What part you don't understand? What part is weird? What part is complicated? What part is confusing? What part you don't see? Guys, I give you opportunity to ask you, okay? Remember, as your friend, I always want help. But I can help to the 1 point. Another point, no. Okay, now what is the next? The next is 33. 33. 33 now. Another logarithmic equation. Okay. This is weird. Logarithm of base 8 of negative x. Remember, to be true, we need an x negative value because double negative, negative of the value and negative of the formula become positive. Any solution negative may be worse, maybe, I'm not sure, I need to prove. But positive solution, no. Because positive and negative, and the argument negative inside the logarithm is impossible. Cross logarithm base 8, again, of x minus 20, x minus 20, x minus 20, yeah, f minus or f plus? F minus. F minus. Is equal to logarithm base 8 of 96. This is my equation. Okay. Let's do it. As always, you condensing this and this in only one logarithm. Okay, logarithm base 8 of the multiplication minus x, x minus 20. And this is the new argument of this logarithm que condense this and this in only one. Equal logarithm base 8 of 96. Okay, you delete the logarithm because it's the same, and you have the equation like that. It's minus x, x minus 20, equal 96. Okay, ready to be distribute the properties minus x squared, 20x minus 96 equal to 0. Okay, I don't feel comfortable with this equation. I multiply the whole thing by -1 to get positive here, and the quadratic minus 20x plus 96 equal to 0. Okay, cool. Now my problem is solving this quadratic equation because it's super easy. What do you think? Factorization is good or no? Or quadratic formula? What do you recommend me? Solution the quadratic equation. This is nothing for us because we are advanced students. This is for elementary, intermediate algebra.
I would factor
What combination you see, miss?
12 and 8.
Yeah, you are right. She said that 12 and 8 is possible because 12 times 8 is 96. Nice. And somehow 12 plus 8 is 20. What sign? What sign? What sign? I put in the factorization. What sign?
Negative
Both?
for both. Yes.
Yeah. So one solution is positive 12 and another solution is positive 8. And that's it. I gotta go. What should I do now?
Check.
Check. What do you think? According to the thing I explained at the beginning, remember, this equation that we have minus and one logarithmic. That when you try to check in any positive number in the first logarithm and the first one, you see negative value, no? And negative value to be on the 5. So what do you think about the solution of this equation? Do you follow me? Do you understand the thing I am doing? Or I try to explain? Do you want me doing? And the checking part. A ver. No solution. Yes, Edward say no solution. You understand that this solution doesn't work when you try to check in the original equation. And no solution is the option C. Look at that empty set. That symbol. Empty set, no solution. Do you understand this idea or no? Or it's confusing? I understand. Okay. Okay. Okay, Gladys. Okay. This was 33. Now 34. Okay. 34 is, okay, it's weird. It's logarithmic base 7 of 3b plus 23 plus logarithm base 7 of p, and that kp is the variable, p is equal logarithm of base 7 of 36. Exactly the same. We're condensing the left-hand side using the property number 5, allow us condensing several logarithms, not necessarily two. You have 20 logarithms, you condense in only one. A multiplication p times 3p plus 23. Inside the argument of the logarithm is equal logarithm base 7 of 36. Now again, we have the same situation. The logarithm of the same base, therefore the argument is the same, and the reason, the fundamental reason is because that function is one-to-one function. It's no good, no, delete that, chat. Some people, the majority of people doing this, but actually this is not good. Okay, so now we have a quadratic equation again. 3p squared plus 23p minus 36 equals 0. Oh, this is by factorization. It's a little bit complicated, right? Because I prefer doing by quadratic formula. Doing a is 3, b is 23, and c is negative 36. I apply the formula. Minus b plus and minus square root b squared minus 4ac divided by 2a. In our example, b is 23. 23 squared minus 4 times 8 is 3 times 36 is minus 36. Be careful with the sign, it's super important. Divided by 2 times 3. Okay, now calculate. You put in your own calculator here, you focus in the expression inside the radical. Compute 23 squared. I'm doing my calculator I have in my hand. 23 squared is 529. Now plus. Why plus? Because we have double negative. And this is 4 times 3 is 12. 12 times 36 is 432. And together plus 529 is 900 equal 961. And now you find the square root. Remember, the thing we are doing is the expression inside square root. Now I need to find the square root. And the square root of this number is, let me see if it's perfect square or no, I don't know. Is square root 961. Oh yes, it's 31. Okay, it's perfect square, it's 31. Now we have 23 minus 23 plus or minus 31 divided by 6. Get the multiplication. I separate two pieces. Minus 23. 31 divided by 6. And minus 23 minus 31 divided by 6. Remember, this plus or minus is not good for me. I split in two pieces. Compute separately each piece, and that's it. The answer is, well, 31 minus 23 is 8. 8 divided by 6, and lowest term, a fourth term. Now 23 and 31 together with the same sign of 54. It's minus 54 divided by 6 and negative 9. I suppose que negative 9 doesn't work because when you plug in here this negative 9 for checking, at least in this part doesn't work because of negative number. So I need to verification only for third. Definitely this doesn't work. However, for third, I don't know. I need to verify. So I need to multiply, no, plugging in. This is 3 times order 23 plus logarithm base 7 of 4 over 3 should be logarithm base 7 of 36. Es obvio que this is cancelled. Es obvio que this is cancelled. Okay, entonces we have logarithm base 7 of 4 plus 23, que es 27. Plus, and we have fraction here, wow. Logarithm base 7 of 4 over 3 should be this. And you condense, why no? Entonces, logarithm of multiplication 27 times 4 divided by 3. And 27 divided by 3 is 9. And 9 times 4 is 36. We get exactly the same answer. Okay, and the solution is perfect. Author. Any question? What part you don't see clear? 34, no? We're doing 34. 34. Everything is good? Everything is good? Something wrong? Something wrong? No. Everything is good. Okay. Remember, today I sent the test, no? I don't remember if I sent before. This is due November 9. And by the way, November 9 is a weekend. No, weekend. November 9 is Wednesday. So Wednesday, I suppose we start new chapter. But Wednesday 9, November 9, 9 is due. Test. Therefore, I grade number 10 of this Thursday. Okay, 35 is, let me copy, is log of x, I like to put the parenthesis, always log x minus 8 equal log x minus 20. Wow, but there's something weird in this equation. In this equation, I don't see what is the base of that logarithm. What do you suppose can happen here? I don't see. Because it's 10, it's obvious, it's common logarithm, yes. So likewise, you condense this and this in only one logarithm using the property phi. The base is 10, default. And when this situation happens, it's omit. Everyone in the world understands very well this. X times x minus a is the argument of this is equal logarithmic of the x minus 20. Now, same base, same logarithm. Now I delete everything and taking only the argument inside this because this is one-to-one function. I have manipulation a little bit, look like quadratic equation. When you distribute here, okay, I move minus x plus 20 equal to 0. Actually, we have x squared minus 9x equals 0. Cool. Now you see it gets important, the quadratic equation, guys. Extremely important. Always we ending in quadratic equation, the majority of the time we ending in quadratic. Entonces, who help me? We can do that by factorization or no? Or quadratic formula.
Factorization.
Okay, what is the combination that open the door?
5 and 4.
5 and 4. 5 and 4. What sign?
Negative for both.
Negative for both. Therefore, one solution is 5 and one solution is 4. As always, I need to check it. But unfortunately, what's going on when you're checking? Look. At least when you plug in 5 and 4 here, 5 minus 20 is negative number, and 4 minus 20 is also negative number. And this, no. It's okay. But in this, no, because 5 minus 8 is negative, and 4 minus 8 is negative. It says to be undefined here. Undefined here and here. So what is the conclusion? No solution. Very well. It's this symbol. There are many ways to express no solution in mathematics. In Word, no solution. This symbol like that, or this symbol, they indicate in both is the same. NT set. NT set is not zero. It's a set que do not contain element. It's NT, no solution. Any question in this problem? No? Okay, cool. Let's move on to the 36. Oh, 36 is easy. It's exponential equation. And remember, in our test, we have a lot of exponential and logarithmic equation. You need to be aware for solving any. Remember the solution for the exponential, we have two kinds. We have this exponential in which we can express both sides. This is exponent, sorry. This is the exponent, this is x squared, right? This is 2x. In this case, we can use in common base. And the reason is because I know very well that 5 and 25 is 5 squared. Be ready to find, this is 5 raised to the 2x, no problem. And you replace mentally 25 like a 5 squared raised to the x squared. And x squared is exponent. You have two exponents, two levels of the exponent, and you multiply. It's 5 times 2x squared. Now you have two exponential and the base is the same, it's because the exponent is the same. Wow, easy equation. Be careful because it's quadratic equation and you have two solutions, not only one. Some people delete this, delete that, x equal 1. No, x equal 1 and x equals 0. How are you solving that? For example, move everything to the one side. And factorization. The common factor is 2x. We have x minus 1. 2 never is 0. Therefore, the only possibility is x0 or x1. And in this kind of equation, never you need to check it. Because you are doing well, of course. The answer is correct because the domain of the exponential function is all real number. Therefore, please accept any solution. 0 and 1. Option D. Any question? No? Okay. I know it's easy. Too easy. Okay. Number 37 is 32 raised to the x plus 4 equal to 6x. Okay. It's also the same idea. 2 and 2. But 32 is 2 to the 5th power. If you multiply 2 5 times, you get 32. You replace 2 to the 5th power raised to the x plus 4 is equal to raised to the 6x. And now multiplication. 2 5 times is a binomial, x plus 4 equal to raised to the 6x. Again, 2 exponential, the same base, get 2. Therefore, the argument is the same. 5, 5, parenthesis x plus 4 equal 6x. Okay, distributed 5x plus 20 equals 6x. Oh, this is a linear equation, not quadratic equation anymore. No. So 20 is equal to 6x minus 5x is 1. X equal 20. Really cool. Only one solution because the problem was ending the linear equation. No two solutions. Only one solution is 20. And you know very well that you don't need to check it. In exponential. No. Let's do it 32. Try here. 30, 30, 32. 32, no. 38 is square 4 root of 16 is equal 4t. Wow, this is easy. This is easy because 4 root 16 is 2, no? And 4 is 2 to the second power, no? So 2 equal 2 to the second power raised to the t. Again, we have two levels of the exponent is 2t. Again, we have two exponential, same base. The exponent here is 1 invisible. Now 1 is equal to t. Divided by 2 both sides, t is 1 half. 1 half. T is 1 half. There you go, function A. Now, next question I did. However, the answer I get is not this answer. Sometimes happen, guys. I am doing, of course, by hand, but I checking in the different software that allow me compute that. It definitely the answer is not here. But okay, let's do it. Sometimes happen, not frequently, but happen. Okay, this package have mistake. You need to be aware that that possibility is true, because it's doing by the teacher, and the teacher is human, no? Not superhero, and sometimes making mistake. 32 exponent is x plus 3 is equal 4, and the exponent is 3x plus 1. I guess so. The problem is that I don't see very well si es x3 plus 1 or no. Or it's another number, maybe. Or it's 7. I assume que es 1. And si es 1, I never get the answer. By the way, I don't check it using. Es It's 7. Okay, so let's do it using 7. Okay. And the other is 3. You say que this is 7. A ver, opinion, what is opinion? ¿Es 7 o no? And another exponent is x plus 3. I look like 7, yeah. Well, let's solve it by 7. See if you get some answer. That's because when I do in the piece of paper, I suppose get 1 and never get the answer. Okay, okay. Okay, but in this case, I can get common base because 32 is 2 to the 5th power and 4 is 2 to the 2nd power. Replace 2 to the 5th power raised to the x plus 3, 2 to the 2nd power, 3x plus 7. Now multiplication. 2, 5 times x plus 3, 2 times 2, 3x plus 7. Now I know okay, we have the same exponential, same base. You omit the base. My equation so far is equal each other the exponent. No? You apply distributive property. It's a linear equation, fortunately. Fix plus 15 is equal 6x plus 14. Well, let me check it. Yeah. Now I solving that either way. For example, I don't know, 6x stay here. I move 5 to the other side. And 15 stay here, minus 14. It's a 1 equal x. X equal 1. Yes, you're right. It's the answer. I did wrong in my piece of paper. Because it's 7 and the answer is 1. Cool. Perfect. Thank you. You know, together we are strong. Okay. Any question? No? Okay, just erase the bar. Moving on to the next question. Next page. The next page is about what page it is? Page number. Not page, no? Yeah, it's that page, no? It's page 11, no? Oh, yes, it's page 11. Page 11. Okay. Entonces, now, what do you consider this big review is good or is bad? Suppose que, yeah, a big review is good. It's good because it's repetition. And little by little, you memorize. 40 is 40. Let me see 40. What is 40? 40 is here. 40. It's 3 to the x is equal 1 over 729. So they want que you solve for x. Okay, and so you need to know que 729 that you investigate is 3 to the 6th power. You multiply in your own calculator. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 again. I suppose que es 243. Let me try. Bueno, 3 times 3 is 9. Times 3 is 27. And 3 to the 4th power is 81. And 3 to the 5th power is 243. And 3 to the 6th power is the famous 729. Cool. But the problem is you have reciprocal. Okay, those actually either way you consider que es negative exponent is 3 to the minus 6. Make sense? Remember, negative exponent indicate us reciprocal. Entonces es obvio que x es minus 6. This is one possibility. Another possibility to do this. No, this is the best way. Do you understand that way? Yes. Let's move into the 41. 41 is, you know, similar. 41 is 7 raised to the 4x minus 4 is equal 1 over 49 raised to the x. Entonces, in this moment, I don't see very well guess. Is you help me because I don't get this answer. Do you have? It's 7 again, no? It's 7 again. Unbelievable. It's 7 again, yeah? Wow. Yes, it's 7. Carajo. Okay, it's 7. Entonces it's 7. I did wrong in my piece of paper because I believe que it's 1. It's 7. Si it's 7, maybe you get the answer. Let me try. Well, I know. So you try to find common base. I know que 7 is 7. 7 is 7. It's 7 to the 1. And 49 is 7 squared, right? But the reciprocal, que 1 over 49, is 7 to the minus 2. Makes sense? Remember, negative exponent is reciprocal. Now you're right. 7 raised to the 4x minus 4 is equal 7 raised to the minus 2 raised to the x minus 7. Okay, this is 7 raised to the 4x minus 4 is equal now multiplication 7 minus 2x plus 14. No? You multiply this times this and this times this. Now, if you have two exponential and the base is the same, it's because the exponent is the same. And you have this equation that, by the way, is linear. Okay, let me try. This is 4x plus 2x is equal 14 plus 4. This is 6x equal 18. Divided by 6 both sides, x equal 3. Wow. Okay, and 3 is the solution. Is one choice to select or no? Oh, yes. Look at that. It's the option B. So si you suppose in the piece of paper gets 7, the answer is 3. This doesn't work. Here the option B. Any question? Do you see or no? Everyone follow me? Everyone is agree or disagree? Totally disagree or totally agree? 100% agree or disagree? Cool? Okay. Let's try next. Okay. Okay. Number 42. 42 look like weird. Is 3 or 5 raised to the 3y plus 9. And 9, no? Yes, it's 9. Is equal 27 over 125 raised to the 4y. This is my exponential equation. Okay, it contains fraction, but it doesn't matter because I know that 3 is 3. 27 is 3 to the third power. 5, 5. and 125 is 5 cubic. Okay, so we have 3/5 raised to the 3y plus 9 is equal, you replace it, it's 3 cubic 5 cubic raised to the 4y. Okay, this is equivalent to say 3/5 raised to the cubic, that you put a cubic outside, and by the way, you put the cubic outside, multiplied by 4y is 12y. Make sense? Now, ready? 3y plus 9 equal 12y. 9 is equal to 12y minus 3y. It's 9, 9y, therefore y1 is the solution. Y1? Yeah, Y1. Option C. Okay. Number 43. Number 43. Any question on this 42? No problem. A little bit artificial, a little bit sophisticated. Or not sophisticated. Okay. 43 is, well, 43 is 100 raised to the 2x minus 1 is exponent equal 1000, and the exponent of the 1000 is 1 minus 6. Again, same idea. 100 is 10 squared, and 1000 is 10 cubic. So we have 10 squared raised to the 2x minus 1 is equal 10 cubic raised to the 1 minus 6. Multiplication of the exponent is 10 to parenthesis 2x minus 1 is equal 10 3 times 1 minus 6. Okay, cool. Same exponential, same base. Exponent is the same. The 2 times 2x minus 1 is equal 3 times 1 minus 6. Okay, entonces 4x minus 2 equal 3 minus 3x. Okay, now linear equation, 4x plus 3x is equal 3 plus 2. This is 7x and this is 5. The answer divided by 7 both sides is 5 over 7. And you don't need to check it. So you are doing well, you have no problem, because the exponential equation always give me good solutions. Okay. Let me try. Next page. We are doing well. We are doing too fast. It's okay. Tell something, guys. Okay. Okay. This is the last page or not yet? Number, wow, it's a lot of pages graphically. It's okay, it's easy. Okay, you need to be familiar with the graph of the exponential and logarithmic. And you immediately detecting okay, this is the graph of the logarithmic, but the base is 1 over 9. Yeah, I know very well okay, the graph of the logarithmic when the base is, let me try, when the base is bigger than 1, the graph is something like that. And this is the famous point 1, 0. It's increasing. However, when the base is less than 1, the graph is like that. It's decreasing, it's going down, and this is again the famous 1,0. In both scenarios, we have vertical asymptote here. This is my mentally idea. Okay, because I need to see the options. Decay. Es the word. Decreasing. Decay is equivalent. Synonym. To be decreasing. Yes. Because actually, Edward, look, suppose to understand much better this. Let me take advantage of this more. Logarithm of base 1/9 of the 1/9. What is the answer of this? 1/9, I suppose que here. 1/9. ¿Es positive or negative? Es positive. Yeah. However, logarithm base 1/9 of 9, que 9 is the reciprocal of the 1/9. I suppose that 9 is here. Do you see que es negative? Es negative 1. Makes sense or no? Yeah. Therefore, in my opinion, the best option que matching in this scenario is that one. Instantaneously, I see. Doesn't work. But the competition is in between this and this. But this included the famous 1,0 point, and this no. When it's no, it's because maybe you have transformation, but in this case, you have no transformation. It's just logarithmic of the one non-standard base, but it's no transformation. It's just one logarithmic. This idea is super clear or super confusing? Clear. Okay, let's move on to the page. It's a number 12 page. Delete the page 12. Moving on to the page 13, I guess so. That one. Okay. And the page 13. Look, this is very, in my opinion, confusing. Super confused. Entonces, this is wrong. Entonces, I did in one way under one consideration. Entonces, pay attention because there are one question that is similar. In my opinion, when I see again this, you have logarithm base 3 of y is equal x minus 4. Entonces, this is logarithmic function or exponential function? Suppose que no, que es no logarithmic. It's exponential because this expression is implicit. Therefore, you need to isolate the y, and when you isolate the y, okay, y is equal to 3 raised to the x minus 4. And this is exponential. This is my idea. However, in the choice that you have here, an exponential, you know, okay, it's like that. Woo, never is like that. Woo. Entonces, this is wrong. Entonces, the consideration que hay using in a piece of paper, I recommend you in the question, no in the last, in the 24 question in the test. The test have 25 questions. In the 24, you consider actually okay, the only wrong thing is the equation. The equation is not like that. The equation is y equal logarithm of base 3 of x minus 4. Okay? So you are doing exactly the same in your test. You delete this question and you copy in this way. No logarithm of y. No, logarithm of the x. You understand the idea? Uh-huh. What question it is? This is question 45, no? 45. Yeah, 45. 45, no? Let me see. I want to make sure that you understand. You understand, no? Jenny?
Yes, I understand.
That this and the test you are doing that way. Because the graph corresponded with the... Okay, so now I see transformation. So the base logarithmic without transformation, you know, the base is greater than 1. So it look like exponential like that. Exponential, no, sorry, logarithmic. In which the vertical asymptote is here. And this is the famous point 1, 0. And this is increasing, not decaying. It's increasing. Okay. Now, but this is -4. And -4 represent the horizontal shift 4 units to the right. Okay. Therefore, this asymptote is located normally without transformation at x equals 0. Now it's located at x equals 4. To confirmation everything is okay, and the option A is, okay, for example, if you evaluate at 5, you evaluate here at 5, 5 minus 4 is 1, and logarithm 1 is 0. And this is the famous point 5, 0. This is the confirmation 5, 0. Let's check in domain and range. It's obvious that the domain is from 4 to infinity. This is our domain. Look, that part. And now the range is all real. And the vertical asymptote is at x equals 4. Super cool. This is the answer. Any question? It's confusing because sometimes this packet have mistake. In this case, it's mistake, definitely. So I copy in the test, but you modify. Okay? Okay? You modify. Not like that. This is the original. No, this is not logarithmic, it's exponential. You modify like that. Y alone, a logarithm. Of course, this is not equivalent. It's different statement, but this is the idea. Do you understand very well?
Yes.
Cool. That was 45. Now 46. Next page is 14. Okay, 14 page. 14. Yeah, we had 16. We have 2 more pages, but that's no big deal. Okay, there we go. Okay, now we have again, we have a function que es logarithmic y equal -2 plus logarithmic base 4 of x. But this is base 4. Yeah, I know very well que base 4 look like that. And this is the famous point 1, 0. And we have vertical asymptote here. But this -2 represent only the vertical shift down. Well, entonces the asymptote stays the same because the asymptote is vertical. So you are doing a vertical shift, it's obvious que the asymptote doesn't affect because it's vertical. Stay the same at x equals 0. But the thing is affect is the value of this, que es obvio que my logarithm is a little bit down to unit, no? Pero the asymptote stays the same. So this famous point, que is the point 1, 0, now would be the point 1 comma negative 2, no? Because 0 minus 2 is negative 2. So in my opinion, is the option D. Let me show you. Let me make a zoom. The asymptote obviously stays the same at 0. This doesn't change. But the point is 1 comma negative 2. Get 1 here, negative 2 here. This point is 1 comma negative 2. Domain is always positive number. That this is the domain. Range or real number. That's all we have in the logarithmic. And the asymptote stays at 0. Cool. Option D. Any question? Do you understand or no? Do you understand that this negative 2 doesn't affect the asymptote? Because the only asymptote that we have in the logarithm is vertical. So you are doing a vertical shift, the asymptote stays the same. Do you see or no? Okay, one more, 47. 47. It's the page 15, no? Yeah. Yeah, almost we finish. Page 15, the only consideration is, well, is that the base of this logarithmic is greater than 1 logarithm of 5. X minus 4 minus 3. Now the base is 5. This is important information. So immediately I ignore this possibility and this possibility because it's increasing, right? The logarithm will look like that. The problem is that we have x minus 4 and x minus 4 change the asymptote. Okay, normally our asymptote is here. But you change, you move, this is represent horizontal shift. Now therefore you need to say is something like that. Yeah, the new asymptote is at 4. But we have minus 3 that represent a vertical shift. A vertical shift is going down 3 units. I suppose here is B, right? This is no. This is not have no vertical shift. It's B. It's B option. Do you follow me?
Yes.
Let's do it quickly. 48, 49, 50. And that's it. 48. How do you feel in analyzing the graph? In the test, unfortunately, we have no multiple choice. You need to create your own graph. My recommendation is you analyze good like that. However, I recommend can you verify in decimals, no? Put in decimals, wow, and you see, wow, and you make a copy in decimals and attach to the test. Suppose in 48 compute logarithm of 1 over e to the 6th power. Wow, I know very, very well. It is equivalent to say e to the minus 6, no? You know very well that logarithm and exponential on those each other, and the answer is minus 6. And 49 is logarithm base 1/2 of 32. Wow, I don't have idea what is the value, but I suppose it's negative because 32 is greater than 1. 1/2 is less than 1. There are contradictions. See, both numbers are greater than 1, both the base and the argument. Then the answer is positive. Or the base and the argument are negative, so the answer is positive. But when there are contradictions, it's because I need the negative exponent to make reciprocal. But suppose I have no idea. Yeah, I set out this statement to exponential. to understand much better. The base is 1/2, the exponent is exactly, I try to find, is x, and this is 32. And we are in front one exponential equation. It's super easy to solve it because okay, let me erase that part, because I know okay, 1/2 is 2 to the negative 1, and 32 is 2 to the 5th power. So it's 2 raised to the minus 1 raised to x is equal to 2 to the 5th power. And now multiplication, 2 to the minus x is equal to 2 to the 5th power. Then minus x is equal to 5. Therefore, 5x is equal to 5. The answer is 5. 5, 5, 5. C, 5, C. Option. Let's do the last one. The last one is easier. Let me show you. Image device. Last one. A16 have only one problem. And this problem is, wow, it's a common logarithm of 0. How many 0? 1, 2, 3. 3 0, no? 1, 2, 3, yeah. 1, 2, 3, and 1. So you express an exponential, so 0.0001 is equivalent 10, 1, 2, 3, and 4. 10 to the negative 4, no? 10 to the negative 4, because it's 1, 2, 3, and 4. This is equivalent to, say, logarithm of 10 to the negative 4. We are using the property 7, and the property 7 allow me, this exponent go to the front. Here, minus 4 logarithm of 10. I forgot the parenthesis, and close the argument, and logarithm of 10 is 1, because the base is 10, and the answer is negative 1. Final answer. Okay. Okay, guys, entonces nada, we finished chapter 4, chapter 3, sorry, chapter 3. Chapter 4 is very, very hard. Very, very hard. In my opinion, it's the hardest chapter. This is no, number 3 is no easy, but it's no big deal. Okay, so now, how do you feel for this? How do you feel? Okay, super. Come on, working. Remember, send to me Wednesday at midnight, because the Thursday in the morning I grade that, and submit and Alex online. Okay? Everything okay? Are you clear the thing that you should do? Any problem, you let me know. Any problem, you communicate with me. If you ignore me, I don't know anything, I put 0. Okay, so say now, okay. You try to do your best. And remember, important. And the written test, you show me your word in detail. Exactly the same I show you in the whiteboard. Okay? No final answer, no. Word in detail and write clear. No Chinese. Chinese, I don't understand. Okay? Bye, guys. See you.
Bye, Professor.